So chapter 4, section 3, number 33, they want us to graph this and find every possible detail that we can. So ln of x, you better know, everybody, what it looks like. It looks like that. So we already know our domain is going to be from 0 to infinity, just because that's where ln of x exists. So I'm down to that domain. It's the first thing I notice. Now, we have a lot to do here. We could find X-intercepts and Y-intercepts and all that kind of good stuff. So let's do that. Take care of some of these X-intercepts. That's when y is 0. So we just say 0 equals x ln of x. When does that equal 0? When x is 0, right? When x is 0 or ln of x is 0. Well, x is 0 isn't part of our domain, so we ignore that. When is ln of x equals 0? You e both sides to get rid of the ln, and then you get x equals e to the 0 or 1. So I have one x-intercept at 1. How do you find y-intercepts? Well, that you set x equal to 0. And again, we have a problem. F of 0 is 0 times ln 0. Now, ln 0 doesn't exist. It's not part of our graph. So we're not going to have a y-intercept. Well, clearly, because, duh, we start at 0. Or 0 is not even part of our domain. It doesn't exist as 0. So why would we have a y-intercept? Makes no sense. Duh. Duh. Yoshida. Okay. Now we're going to find relative maxes, relative minutes, increasing, decreasing, all that stuff. So we need the derivative. Product rule, leave the first alone, take the derivative of the second, plus take the derivative of the first and leave the second alone. So now we have the derivative is 1 plus ln of x, because those x's canceled. That seems too easy. Is that right? Leave the first alone and take the derivative of the second. Take the derivative of the first. Okay, that's right. So what are critical points when this equals 0? We're going to subtract 1 from both sides. We're going to e both sides to get rid of ln. And we find our critical point is e to the negative 1 or 1 over e. So now we have found a critical point. Now, is that a relative max? Is that relative min? What's going on? I don't know. So let's do this. 1 over e. 0 is our left endpoint. Infinity is the right endpoint. So I'll put that in. So e is about 2.7. So a smaller number would be 1/4. And a bigger number would be 1. I like those. And we plug it into the first derivative because we're looking for relative maxes, relative mins, and what else are we looking for? Relative max, relative min, and increasing, decreasing. That's what it is. So let's plug in 1/4 there. Now, I'd have to do that in a calculator because I'm not that smart. I should have picked a better number, but we're okay. ln of 1/4, 0.25. ln of 0.25 is negative 1.38. So negative 1.38 plus 1 is going to be negative. So we know at 1/4 it's negative. Then we're going to plug in 1. So ln of 1 is 0, right? So 0 plus 1 is 1. That's positive. So now we know it's decreasing in this region, increasing in this region, and there's a relative min here. So we know there's a rel min at 1 over e. So let's find the y value. F of 1 over e is, which is f at e to the negative 1. We're going to plug that into the original here. So that's e to the negative 1, ln e to the negative 1. these cancel, and so we get e to negative 1 times negative 1, which is negative 1 over e. Yes, and I will tell you the y value of that. 1 divided by e is about 0.37. Okay, so we have a relative min at 1 over e and negative 0.37, which is, okay, I'll write this out. Relative min at 1 over e, negative 1 over e, which is about 0.37. Wow. In my old age, I'm getting dyslexic. 0.37 comma negative 0.3. You see that? I don't know how to write. Oh, what's wrong with me? I did it again. I need lunch. Okay, so relative min at 0.37, negative 0.37. I'm going to graph that point, and to make it my life easier, I'm going to go, this is 1, this is 2, this is negative 1, this is positive 1. So 0.37, negative 0.37. 0.37. You know what? Sorry, but I'm going to make it even bigger. So I'm going to make 4 of them. That's going to be 1. And that's going to be 1. And that's going to be 1. So to go 0.37 and negative 0.37, that's going to be our minimum point that we found right there. Okay? And we know it's decreasing prior to that and increasing after that. So in our heads, we know it's something like decreasing, increasing, kinda, right? So we know that much. And where does it cross the x-axis? We did that. The x-intercept was 1. So let's go ahead and graph that. The x-intercept is, it's going to cross the x-axis at 1. So I know it goes to that point. So we're getting lots of good stuff here. Now, we got to do a couple more things here. I know we have 7 minutes. We can do this. The left endpoint is 0. What happens at 0? ln of 0 is what? Negative infinity. So, yeah, you know what? We'll get to this eventually. Let's do the concavity first, increasing, decreasing, and then we'll get to our final answer because we have too much stuff to do and we're running out of time. So let's get through this. Okay. Let's look at something here. Okay, let's find concavity. Let's do that. So we need f double prime. Well, the derivative of 1 is 0, and derivative of ln of x is 1 over x. That was easy. But look, when is this 0? Never. When is it undefined? When x is 0. But x is 0 is what? X being 0 doesn't even exist on our graph. So second derivative, it's not going to have any points. So from 0 to infinity, we have to find if the second derivative is positive or negative. It's not going to change signs anywhere because it can only change signs at 0. But 0 is the endpoint, so it's not going to change signs. Pick any number, 1. What's 1 over 1? Positive. So we know it's always concave up. It's always concave up. We know there's a relative min there. It goes to that point. So it's going to be like that. And we need to know what it approaches at 0, like when x is 0. So here's what's weird. At 0, that's undefined. I'm going to just tell you, That at 0 approaches 0. I'm just going to tell you. You don't have to know that. I'm just going to tell you that. So we know there's a hole there. It doesn't exist there, but it's approaching 0. And it's concave up. So I need to draw a concave up graph. And that's what it's going to look like. Okay, that was kind of crazy.